Let us study logical theories. So first question is, what is a theory in terms of logic? So what is the word theory for? If you look at Wikipedia, you will find the following definition. Theory is a contemplative and rational type abstract thinking, blah blah blah. It's basically trying to say that a theory is talking about some subject matter in a coherent manner. For example, you must have heard the theory of gravity by Newton, and theory of evolution, and or maybe if you're in economics, you must have heard the theory of marginal utility. But there are other kinds of theories in our life, okay? For example, you must have heard that some 9/11 was done by American government on itself, or other theories you can see here. Some of them outlandish, and some of them may actually end up being true. They may sound silly, but they make a point. They make a point that in a subject matter, there is a closed set of ideas, and those ideas are internally true. They may not be true to the outside world, but within the system of the theory, they make sense. So why you need theories on top of first order logic? A first order logic provides a grammar for process of thinking, but it does not provide you any understanding of the subject matter. This was not entirely obvious when we start investigating logic. This confusion led to a very strange investigation, such as when Descartes wanted to prove that God exists by simply analyzing the internal structure of logic. Of course, he did not succeed. Later we realized that the first order logic, the structure of logic, is a separate thing, and the subject knowledge is a separate thing. So when you put them together, that becomes a logical theory. So theory can be defined in two key ways. One is a set of acceptable structures. You can say, what is the set of models or structures we can think of is true about this world? Or another way is that we can talk about the set of sentences that are true in this world. We will consider both and see what is the better way, or which one is a more convenient way. For example, we can describe the natural numbers using its model or structure. And every sentence that is true on this structure is a valid sentence in this theory. Now let us go and define a formal definition of theory. A theory is a set of sentences, nothing more, just a set of sentences closed under implication. i.e., if theory implies a formula, then the formula should be within that set. Pictorially speaking, let's suppose theory is given to you as a set T, and a formula is implied by that set. Then the formula should be in the theory. So once you have a theory, you can define theory satisfiability, theory validity. What we say is that something is theory satisfiable if there is a model M that satisfies all the sentences within the theory and the formula under consideration. Okay, so we can write in the following way that the structure M satisfies formula F under the theory T if the M also satisfies the theory T. So we will not consider those models that do not satisfy theory T. We can extend this idea to define theory validity. A formula is theory valid if theory implies the formula. We also write theory validity in the following form. For example, consider the theory of natural numbers, which includes all the true sentences about the arithmetic over natural numbers. For example, consider this formula. There exists an x when x is greater than 0, which is not a valid sentence in first order logic. Since we can interpret 0 in any which way in first order logic, so we can create a structure in which this formula will not be valid. However, we see that the theory of natural numbers did imply that 0 is the smallest number. Therefore, this implication must hold. And we can write this validity statement in this form. Let's look at satisfiability. Now let's say that there is something smaller than x. Okay, the statement is saying that, which is a satisfiable sentence in first order logic. They can create a structure in which 0 is not the smallest number. But if you think in the theory of natural numbers, there is no structure that satisfies all the formulas in the theory of natural numbers and the formula which is given here. Therefore, this formula is theory unsatisfiable. Now, there is another way of defining theories. This is slightly a non-direct way. Let's look at the definition. Let's suppose I give you a set of structures over some signature x. So I will define theory of M, okay, as follows. You collect all the sentences such that all the structure M of capital M satisfies formula F. So pictorially, let's try to understand the definition. I give you a set of structures M. Then what do? You pick an M and you find formulas such that all the structures in M satisfy their formula. Collect those formula, they define the TH of M. Now the question you ask, is it a theory? Okay, so let's prove a theorem that the set constructed in this way is also a theory. So the claim here is that THM is a theory. So let's see how do we prove that. Consider a formula F such that THM, this is set of sentences, implies F. That means F is true in every structure in M, because this theory has only those formulas that are true in all the structure of M. M must be satisfying F. Therefore, F must be in the TH of M. Therefore, TH of M is closed under implication. Therefore, this is a theory.